Good morning students. In the previous class as we discussed about polynomial and what is the degree of polynomial and type of polynomial on the basis of degree that are linear, quadratic and cubic polynomial. Now today we are going to discuss some questions related to these concepts. The question 1 is, what is the degree of polynomial? Degree, as I already told you in the previous class, the highest power is known as degree. In this statement, 5x cube plus 2x square minus 7x plus 1, here highest power is 3. So, degree will be 3. Question 2. A polynomial of degree 1 is called dash polynomial. As I already told you that polynomials are linear, quadratic and cubic, and a polynomial of degree 1 is called linear polynomial. Next question. The degree of constant polynomial is always dash. Constant polynomial. In constant polynomial, there is no any variable, and as there is no variable, so there will be no degree. So degree of constant polynomial is always 0. The next question is, what is the degree of polynomial x plus 1, x minus 2? In this statement, firstly, we need to solve this statement to find the degree. So we will multiply these numbers and then we will find the degree. We multiply x by x, that is x square, x with minus 2, that is minus 2x, plus 1 multiply x will be plus x, plus minus minus 1 multiply 2 will be 2. We don't need to solve it. Here highest power is 2, so degree will be 2. Question 5. If a polynomial has a degree of 3, then it is called dash polynomial. Polynomial in which degree is 3, that is cubic polynomial. Next question is, a polynomial with a degree of 4 is called dash polynomial. Here this concept is new for you because we don't discuss about degree of 4. So I will tell you what is the polynomial in which degree is 4. That is known as a polynomial in which degree is 4. That is known as quadratic polynomial. Quadratic, it is not quadratic, it's quadratic polynomial, or we can say it is biquadratic polynomial. Quadratic means power 2 and bi means multiply by 2, that is 4. So power is 4, we can say it is quadratic polynomial. Now we will discuss next question. Classify the following polynomials as linear, quadratic and cubic. There are 5 parts and we have to tell which is linear, which is quadratic and which is cubic. So in the first, x minus x cube, here power is 1, here power is 3, highest power is 3, so it is cubic. In part B, y plus y square plus 4, here highest power is 2. So it is quadratic polynomial. In part C, the statement is 5t minus root 7. Here variable is t and its power is 1. Highest power is 1. It is linear polynomial. Part D, statement is 4 minus y square. Here highest power is 2. Again it is quadratic polynomial. The last part is statement is x plus 1. Here the power of variable x is 1, so it is linear polynomial. So in this question we discuss which are linear, which are quadratic and which are cubic polynomial. In the next question we have to tell which of following are polynomial. This is a concept in which we have to tell whether a statement is polynomial or not. How can we tell whether it is polynomial or not? What are the conditions in which a statement is not polynomial? There are two basic things we need to remember. The things are that whenever there are negative exponents or variables under a radical. Radical means root. Whenever we find in a statement the exponents are negative or variables under a radical, or we can say when variables are on the position of denominator, then statement is not polynomial. Now part 1a is 4x square minus 3x plus 7, and we have to tell whether it is polynomial or not. As in this statement power is not negative, variable is not in the position of denominator, or there is no any root on the variable, so it is polynomial. Part B, here we can see there is root on variable x. It is not polynomial. In part C, the statement is y plus 2 divided by y. This is also not polynomial because variable y is at the position of denominator, or we can say it is not at its accurate position, that is up. Part D, statement is y square plus root 2. This is a polynomial. We need to remember one thing. Root radical should be, if radical is on the variable, then it will not polynomial. Okay, we have to look the variable whether it is accurate or not. If there is root on the variable, that will not a polynomial. Thanks.